All right, I'm making the key for the homework, so I decided, you know what, I might as well do make a video as I'm doing it. So I apologize if I make mistakes here and there, but at least you'll have an idea of what needs to happen. So this is the first question on page 59 in your notes booklets, and so you read the question, and we know that they both are Marlene and Candace have the same height essentially when they're stretched out their arms. On a given play, Candace is 1.75 meters from the left edge of the court when she sets the ball to Marlene, who is 4 meters from Candace. Highlighting important information. The ball reaches a maximum height of 3.5 meters. That is an indication that that's a partial information regarding the vertex right there. Their coach wants them to create a polynomial function that models the height of the ball over the horizontal distance width of the field. So we're kind of considering the edge of the field. This one right here is 0, 0, right? And but I kind of just made a little sketch here. So if I consider this the edge of the court, then Candace is 1.75 meters, right, away from the edge of the court. And Marlene is 4 meters from Candace, right? So we've got, that's going to help us put this puzzle together. Now, I know that both of them standing, so this is the edge of the court, right? Right here. So they're not quite on the edge, right? 1.75. So I know that the coordinates to this first point is 1.75, 2.1, right? From the edge. And then this one would be 1.75 plus 4, right? With respect to the edge of the court, which is for us like, right, this is our y-axis, so we measure from there. This would be 5.75, 2.1, okay? The coordinates to, so we have both of those points now, and we kind of imagine, right, that it's happening like this is the kind of like how the ball is set. It's going to have a parabolic shape. And so we assume that it's going to be halfway in between the 2 points. That's where we have our vertex. And so we have partial information. And this is a maximum height of 3.5. So we got to make sure 3.5 goes there. And we have to figure this out. So you basically find the average, guys. I don't know if you remember grade 11 applied, we talked about the axis of symmetry, right? Is the line that cuts it in half. So we're just going to add these two x values divided in 2, and then we're in business. And you're like, why can't I just divide this by 2 and get that? Because we're not measuring, right? We're not measuring from here, or sorry, from the end, right? So we're used to start here or here, so it's a little different. We're starting here, right? So we need to, in a sense, find the average between these 2 points to get the middle. So we're just going to go to get that x value of the vertex, or the equation of the axis of symmetry. We just go 5.75 plus 1.75 divided by 2. All right. And that 0.75, that's 1.5, right? Put that to the side. 5 and 1 is 6. So 7.5 divided by 2, which is 3, no, sorry. What is it, 3.75? Yeah, that is 3.75. I'm just going to double check. 3.75, never mind, 3.75. So I've got that. So this is right there, the coordinate of that missing piece there. Okay, so I'm going to take this and plop it in there. So yes, you're still dividing by 2, but you're dividing the average, right? You're adding up and dividing up. You're basically finding the average here. So that's 3.75. Okay, so you've got that. So this is one of the more complicated ones. But of course, when you do your homework and stuff, to really understand that, you always want to get more challenging questions, right, to help you through it. And yes, it's assumed that this would eventually perhaps start at 0, 0, but we don't know for sure. We just know that these coordinates here those are the ones we can most definitely use for our quadratic equation, right? So we go ahead and we go distance and height. We put our chart together. It's 1.75, 2.1, then it's 3.75, 3.5, and 5.75, 2.1 again, right? So we are at the start and at the end of that. So we are in business here. So we're going to put this in L1 and this in L2. We're going to go stat, calc, quadreg in this case. So make sure you write that down. And if you're watching this, that means that you're doing your homework. So way to go. Or you're just checking to see if you got it right. So we type that in. So you can fast forward this part. Not very interesting. Okay, quadratic regression. Performing it, and there it is, negative 0.35 x squared plus 2.625x minus 1.42. That is odd, right? We're not used to that, but that's okay, because this curve is like the way this is telling us it's actually going to go through here, right? Like somewhere in the negatives. It's okay. We're only interested in modeling this stretch right here. Okay, so it just happens to be the case. So that's still our quadratic equation. So there we go. So let's answer more. B. How high is the ball when it is 3.23 meters from the edge of the court? Right? So we're basically saying, hey, if this is 3.23, what's the y value, right? So you have to use, let me see here, second trace 1 for value, and then let x equal to 3.23. And I'm going to introduce something that I don't do enough here in this course because we're so used to using our calculator. But here we go. I'm first going to do it the way we're used to. Hold on. Something is, I guess I'm used to doing a zoom 9, but I'm going to adjust my window slightly. There we go. And so second trace 1 is equal to 3.23, and that's, we're at a height of 3.41. 3.41 meters. That's how high the ball is there. So that would be answering that question. And then this is the alternative. Or remember, this is your equation here. You can actually you can plug in this x value and plug it in there. So y is equal to negative 0.35 3.23 squared plus 2.625 3.23 minus 1.42. So you can always, whenever you get the x value, you plug it into the equation and you can still get the same answer. And I will show you that, right? You're going to see the edge probably. So here we go. Negative 0.35, 3.23 squared, close bracket, and then just keep doing that, the rest, typing it in exactly the way you see it. It's going to be off probably by a little bit, but no, in this case, if we round, it's still 3.41. Okay, so either this or this, regardless of how you do it, is fine. I'm going to come up with a domain and range because that's what C is asking us for. Determine the domain and range between the two players, right? Between the two players. So we know that it is 1.75, right, horizontally, 1.75 to 5.75. And our range is basically the height, right? 2.1 is the lowest and 3.5 is the highest. So 2.1 to 3.5. In this case, we don't need to do any extra work. We just read it off of our graph there, that one that we created. If Marlene were to miss the ball, how far away from Candace does it hit the ground, right? So if Marlene is here, like getting a set, misses the ball, right? And the ball then hits the ground here. So we're going to figure out our x-intercept. So y2 is equal to 0. Second trace intersect. So let's go ahead and do that. Y2 is equal to 0. There we go. So we're interested in that point right there. So second trace 5. And if, yeah, you can get it there, 6.91, right? X is 6.91 meters, sorry. Uh-oh. How far away from Canada? So you got to watch carefully because it says how far away from Candace. This is 6.91 from the edge. So that's why you have to read carefully, right? This is how far it is from the edge. So if you count from the edge, right, all the way to where it hits, that is 6.91. Okay. But we want to know how far from Candace does it land, right? If this is 6.91, we're going to subtract. This is the 1.75 mark, right? We're going to take this chunk away, and then we're left how far apart these 2 points are. Okay, hits ground. So distance would be 6.91 minus 1.75, and you're probably wondering, hey, don't you have to use 4 decimals, right? 69123. So I'm just going to go like this. And so it's 6.9123 minus 1.75, and that's 5.16 meters, right? So the ball lands 5.16 meters from, was that again, Candace? They could have asked how far from Marlene, for example. Then you would take this coordinate, the x-intercept we just found, and subtract 5.75 from it, and you would know that, right? So lots of ways to change this question and still make it the same. All right, good. Now we're going to go on. I'm going to pause the video here for a bit. We're doing the arc here in St. Louis, right? This is actually based on an old exam, like a provincial grade 12 applied exam. Okay, the Gateway Arch in St. Louis in the U.S. approximately a parabola. Stephen learns that the arch is 192 meters wide, very important, and the diagram is not drawn to scale. At 2.5 meters from the starting point, right, Stephen measures the height of the arc to be 10 meters. Okay, that's actually depicted right here. Right, walking 10 meters, we know it's across 192, and a point is given, right? 2.5 meters in, it's 10 meters high. Okay, and A is asking us, determine the equation that models the shape of the arc. Show your work. Express all coefficients to 3 decimals. You should know that based on the shape that this is a quadratic, right? I hope. So let's come up with, right, if we draw this in terms of x and y axis, this is a distance and this is height. Okay, you have to assume that you're starting at 0, 0, right? Sometimes it's obvious, right, for students, sometimes not, but that's a very important point. 0, 0 is very important because it could be starting up here, it could be, right? And we know that from one end to the other, it's 192, right? So we are actually 192 across at a height of 0 because it comes back down, right? The diagram is provided. Okay, so you don't need to use the vertex to get that. You're good. And the third point, which is obscure, they never tell us anything about the highest point, but we're given a point right here. It's given. And that point right there is 2.510, right? Once he walks, Stephen walks 2.5 meters, he measures the height. So this point right here actually has a coordinate 2.510. So you actually have distance and height, right? You have your x and y coordinates. You have 0, 0, 2.510, 192, 0. So you basically do have the starting and the end, same height. This one is not the vertex, right? So you don't expect to multiply it by 2 to get that. You cannot find the vertex as is, right? Because you don't know, you need to know at least one piece of information. You don't have that. So in that case, this is a little different. So we go L1, L2, and so this is basically doing A, right? We're doing all the work for A, and then we go stat, calc, quadratic regression. Let's come up with a regression here. I'm going to go to Y. No, sorry. Stat enter. You can fast forward this, of course. Made a mistake there. Okay, stat calc. It's a quadratic regression. And there's C is going to be 0, okay? Don't worry about that, that's 0. So we got negative 0.021 x squared plus 4.053x, and that's it, right? That's a 0 at the end there. So we got our quadratic equation. Now they can ask us a whole bunch of other questions. What's the maximum height of the arc, right? We just go second, trace, max, right? We're going to find the vertex. Let's go zoom 9, right? And it's focusing in on the 3 points that I have. So I need to go up with my window, and I'm going to go to 1,000 or something like that. Oh, sorry, I changed the wrong. I meant to change Y max. So that I'm going to go 500, let's say. Let's try it. Oh, yeah, that works pretty good. And now let's go ahead and find our max. Go to the left of it. Go way past it to the right. Enter, enter. And so we've got 95. Actually, that rounds to 96. 96. And this is 194.53. Right, and now you need to know what's what. This is distance. This is the height. So max height is 194.53, and we are in meters. That gives us the maximum height right there. Stephen walks from left to right and stops when he is 54 meters from the right edge. How tall is the arc at that point? So you walk, walk, walk until you're 54 meters, right? This is 54 meters. So we're asked at that point, right? And I'm not drawing this to scale at all, but we're asked like, what's the height at that? So we know that you might be tempted to say, hey, this is 54, but it's not. It's 54 from this end back, right? But you need to know this piece right here. So we're just going to go 192 minus 54, right? And that's going to give us the answer, the x value in a sense, right? So from this end is going to be 138 meters, because that's what the parabola, if you go second trace 1, then this 54, you're going to find it here. But you're going to find out that it doesn't matter because of symmetry. You actually find, finding this or this, you're going to find the same height, right? So that's one of those things. Second trace value, x is equal to, and I'm going to go 192 minus 54, which is 138, and that goes in here. So second trace 1, and that's 138. That's 157.30. And just circle the answer clearly there, and so that would be it. The city would like to paint the floor underneath the arc where the height of the arc is 180 meters or above. Determine the horizontal distance that will be painted, right? So basically, we're gonna figure out, where is that line that marks 180-meter mark, and it's between those two, right, that we want to paint the floor. So it's basically finding delta distance, right, just like you would find delta time. So we would go like this: y2 is equal to 180, and let's find the intersections. So the first one is 6976.07, 150, 180, sorry. And that second intersection is 122.24. 122.2393, 180. Okay, so I'm going to go delta distance is 122.23 and keeps going. So delta distance that's 52.48. Needs to be painted. Okay, so that's that. Let me pause and do the next one. Okay, this is page 62 in your booklets, and obviously it gives it away, a revenue question, and then it is quadratic. But here you run a canoe rental business, and you currently charge $12 per canoe, right? So it's the cost per rental for 36 rentals a day. An industry journal says that for every 50-cent increase in rental price, you can expect to lose 2 rentals a day. Like I punched out there a bit. Use this information to attempt to maximize your income. What should you charge? So this one shouldn't surprise you a whole lot, right? So at a $12 rental fee, you rent 36. So that's 12 times 36. And so if you increase 50 cents every time, you will lose 2 customers, right? So that's how you fill that in. 1250 times 34. I don't have a lot of room there, so I'm just going to leave it like that. So let's come up with the equation and all that other stuff. And here is where you need to, like when it's open like that, tell me which one you put into L1 and L2. In this case, I tell you to do that, right? To take this one and this one, but really L1 could be either one of these. It's up to you, really. Both of them will give you the maximum revenue. But I'm going to go stat, right? Stat, calc, quadreg, and we're going to come up with our equation. So bear with me. You can skip this step or fast forward. So there's that. And so I have my equation, negative 4x squared plus 84x. Vertex value, we're going to go ahead and find that. Adjust my window. Negative 5 will do. 20, negative 10, up to 1,000, let's say. Need to adjust my window a little bit to the right. And I don't want the 180 there from the previous question, and there it is. So let's go ahead and find our vertex. In this case, it's a max. So that's 10.5, 441. And so that is second trace max, right? Oh, we got that. So Alexis sells. Okay, that's another whole question. Sorry, I didn't see that right away. And so then maximum, what should you charge? Okay, you should charge a rental fee of $10.50 per canoe to maximize revenue. Maximum revenue is $441 per day. That's good enough. Okay, let me pause that there. Due to time, I think I will only do one of these. They always ask the same, so there is no table. So for example, D, right? A dealer finds that they sell 800 passes for 60 bucks each, right? There's a $2 drop in prices. They sell 50 more. What should you charge to maximize revenue, right? So you'd go price, passes in this case, revenue, right? So you kind of make one of these, and you need at least 3 rows filled in. Okay, so at $60, they sell 800, so it's 60 times 800. And at if you drop the price, so 58, then you'll get an extra 50. So it's 58 times 850, and you get the point, right? Drop it another $2, you would get another additional 50. So that's 56 times 900. And, you know, well, why don't we do this into L1 and this into L2, right? So we'll come up with the equation that relates the, oh no.
Good evening, staff. If there's any staff members still in the school or drive.
Sorry about that. In this case, it wouldn't make sense because they're asking you to find the charge to maximize revenue. So this would actually be longer because you'd find the vertex, then you'd find the passes that you would get at that maximum revenue. So you'd have to divide the two to get the price. So I would say instead of making that extra work here, but really it wouldn't matter because I'm not asking you for a specific equation, right? So I'm just going to go stat calc quadreg, and here we go. Tedious work. Okay, so make sure you get that right. There we go, entered it. I'm going to run my regression again. And there it is, negative 25x squared plus 2300x. Boom. And to get the vertex, we'll do that, zoom 9. Let's see if it does anything for us. Not much. I'm going to go on 120,000 maybe. It's a bit much, but that does it. Second trace max, right, for the maximum, because that's all we're asked for in this case. So second trace max, and that's 46 actually. 52,900. 2,900. So he should charge $46 per pass. Okay, that's the price that you should charge to maximize. Maximum revenue is 52,900. Okay, I'll skip that one for now. I think you got it. The next was page 66 to 68. This one is very similar to that as well. Thinking I will skip to page 67 for now, a story. That's a story question. So Gabby is trying to determine the height of a parabolic archway used in a bridge. She's able to find that the arc is 21.5 meters wide and the arc is 3 meters high when it is 1 meter horizontally from the left end of the arc. Uses information above to determine 3 points on the arc. Okay, so I will just have my x and y axis for now. And we have again distance and height. And in this case, I don't need you to draw this with a nice scale. It's just for you to visualize this. So the arc is 21.5 meters wide. So let's assume it's start and end. So we know for sure it's 21.5 meters. And this is obviously 0. The arc is 3 meters high when it is 1 meter horizontally. So we know that 1 meter in, it's 3 meters high. So I don't know, I shouldn't be making my point there, right? I should be making it more like this. So I know that this is 0, 0. And this is over here. And this is 21.50. And this point right here is 1, 3, we're told. So again, you don't need to use the vertex or anything like that to find these 3 points. You are given 3 points. So distance and height, just put it down like this. 0, 0, 1, 3, 21.50, right? This is L1, L2. And we have stat calc 5 for quadratic regression. And we have, let's figure it out. There we go, 0, 1. We have negative 0.15x squared plus 3.15x, and this is 0, all right? So this is my equation. So B, determine the quadratic equation that would model the shape of the graph. So sorry, that is already here. We did B. How high is the arc at a distance 5 meters from the left edge, right? So second trace value, x equal to 5. I'm going to graph that. Zoom 9 is probably going to do a decent job. I need a bigger height there, even higher, probably 150. Oh, I'm increasing my x max, which is not what I want. I want this one higher. My bad. There we go. There's my arc, and I'm going to find that point there when x is equal to 5. I'm at a height of 12.07. Okay, and you just make sure that that's the one that you're circling. So for D, what's the height of the arc at the center of the arc? So that's my vertex, right? Second, trace, max. So it's 10.75, 16.91. This is my max height, right? Max, or height at the center. Height at center is 16.91 meters. There we go. Domain and range, all that fun stuff could have been done yet. And this is the last one. We're done here. Golfer hits a drive from an elevated tee box inside the golf dome. The tee box is 4 meters off the ground, and when the golfer hits the ball, it reaches a maximum height of 12 meters at a distance of 35 meters from the golfer. So again, it's distance and height, right? Use information to determine 3 points on the path of the golf ball. So distance and height, right? And we know that we're not on the ground, we're off the ground. That's 0, 4 here. And the ball is hit, and it doesn't say that it doesn't land on the ground, right? We're assuming that that's happening here. And right away, I'm going to go across, okay, and fill this in here partially. Like, you know that because of the symmetry of the parabola. And then I'm given an indication that, right, so 4 meters off the ground, that's first of all. The maximum height, that's an indication that it's vertexes at play here. And you know that the vertex or the highest point is happening at 35 meters from the golfer. So you need to make sure you put this in the right place, right? This is height, that is distance. So we put the 35 first and then the 12 next. And yes, you guessed it, you can multiply this by 2 and get 70 there. By the way, you're also finding the average between these two x values if you think about it. 70 plus 0 is 70, right? Divided by 2, that's 35, right? So it's still at play here. It's the axis of symmetry, right? So we know that this is true. And I'm supposed to, okay, so this is A, okay? So you have your 3 points there. And for B, we're going to find out the quadratic equation, right? Stat, calc, quadreg. You can probably fast forward this step. That's 0, 35, 70. I encourage you to make a table. 4, 12, back to 4. I encourage you to make a table. Right now I'm not doing that, just interest of time here. So that's 0, 0, 6, 5, why not? Plus 0.4571x plus 4, okay? It all jives, it all works out. Next, C. There's a net stopping the golf balls at a distance of 75 meters. Does the ball hit the ground first, or does it hit the net first? Interesting. So if you think about it, we would have to figure out what this is, right? Is this, if this is less than 75, then it will hit the ground before it hits the net, right? If this is more than 75, then it will first hit the net. So we have to figure that out first. So let's go ahead and determine x-intercept first, right? So we're going to go y2 is equal to 0, second, trace 5. I have haven't adjusted my window yet, so I'm going to go 100 here. This seems to be fine. You don't even need it. Oh. So let's find out. Oh, 77, 86, 87 actually. Right. This is where ball hits the net before it hits the ground. I hope you understand that, right? Because this is 77, 87 here hitting the ground, but there's a net somewhere in here. Okay, it's hard to, this is the net at 75, right? 75. And so it hits the net before it hits the ground, because this is when it would have hit the ground had the net not been there. Okay. D. What is the closest distance to the golfer at which the ball is over 10 meters off the ground? The closest distance. So it's basically the first instant that happens. So, second trace 5, or intersect. So we're going to make y2 equal to 10. Second trace 5. And we want that second, or the closest to the golfer would be the first instant. So that's 17.5. 17.5 meters. Closest distance is 17.5 meters. I would like to add the domain and range. If it hits the net, if that's where the action kind of stops, right? Assuming it hits the net, this would be 0 to 75. And my range would be, we have to figure that out, right? We have to figure out at 75, at this point right here, right? 75. I'm not going to draw that in there because when I scan that, that's going to probably throw people off if they don't watch the video, right? But 75, so I'm going to go second trace 1, x is equal to 75. I will figure that out. And that is y is 1.55 meters off the ground there at that point right here where it would hit the net. So really my range is 1.55, right? That's the lowest it gets, all the way to the highest point, which is 12 meters way up here. That's just an aside. Assuming story ends when ball hits the net. Okay, so that's that. All right, I hope this helped. The rest we will do later this week. All right, have a good one.